Hello there and welcome back to the Sleep Science. Tonight your pillow turns into the cold hull of a telescope drifting through the black ocean of space. You can almost taste the metallic chill of starlight as the galaxy hums around you, quiet and endless. Somewhere out there, a small rock, or maybe something else entirely, is slipping between the stars. You probably won't survive this trip through the void, but don't worry, we're only dreaming. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me in the comments where you're watching from and what time it is where you are. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift in orbit, weightless, watching the Earth curve below, a blue marble wrapped in clouds. The stars beyond it flicker like silent static. Somewhere past Neptune, the solar wind is a faint whisper, and beyond that, true night begins. For billions of years, only the Sun's family, its planets, moons, comets, and dust, has circled here. But then something changes. It begins with a single, faint dot of light, a flicker that shouldn't move the way it does. Astronomers at Haleakala Observatory in Hawaii squint at the data. It's October 2017, and the Pan-STARRS telescope is quietly recording the routine ballet of near-Earth asteroids. But this object is different. It's moving too fast, slicing through the solar system at nearly 87 kilometers per second, way above the escape velocity. This one isn't bound to the sun, it's just passing through. They name it Oumuamua, a Hawaiian word meaning scout, or messenger from afar arriving first. You can almost hear the hum of servers crunching orbital data as astronomers double-check the math, half expecting the computer to spit back an error. But no, it's real. This is the first confirmed interstellar object ever detected visiting our solar system. You, floating here, realize you're witnessing something that's literally from another star. Now here's your first fun historical fact. Back in 1801, when Giuseppe Piazzi spotted Ceres, the first asteroid between Mars and Jupiter, astronomers had no clue what to call it. Was it a planet? A comet? Something in between? That confusion ripples forward 2 centuries to this exact moment. Because now, once again, scientists are staring at a skyrock that refuses to fit any category. At first, Oumuamua looks like a faint dot in telescope images, flickering as it spins. Its brightness changes by a factor of 10, suggesting it's either very long, like a cosmic cigar, or extremely flat, like a cosmic pancake. But there's a problem. It doesn't show the fuzzy coma or tail typical of comets. No gas jets, no dust streamers, just a naked, tumbling shard. Somewhere in the control room, someone jokes that maybe it's a piece of alien hardware, an ancient probe from another civilization, finally drifting past us after millions of years. Most scientists laugh, mostly, because deep down you can feel it too. That tickle of curiosity that says, what if? A quirky tidbit for you. There's actually a real serious paper by researchers at Harvard that proposed Oumuamua might be a light sail, a wafer-thin object pushed by sunlight. Think of it as a cosmic post-it note someone left drifting between stars. Whether they meant it literally or provocatively is still debated, but it became one of the most viral astrophysics stories in decades. Historians still argue whether the true scientific revolution of our century began with gravitational waves or with the day we realized our solar system had visitors. Both discoveries broke the illusion that our patch of space was closed and quiet. Turns out the Milky Way is more like a cosmic highway, littered with stray travelers from 1,000 forgotten worlds. As you drift deeper into the narrative, you imagine Oumuamua's home system, somewhere light years away, orbiting a sun long lost in the haze of distance. Maybe it was once part of a planet, chipped off in a collision and thrown into interstellar exile. Maybe it's been coasting for billions of years, slowly baked and eroded until only this strange shard remained. It has no purpose, no course, just momentum and time. You float alongside it now, watching the sun shrink behind you. The object's surface glints faintly, reddish, metallic, scarred. It tumbles end over end once every 8 hours, like a bottle spinning through dark water. You reach out, but it passes straight through your fingers. In this dream, you're only a ghost riding shotgun on a rock that remembers another star. Back on Earth, the world buzzes with theories. Every university with an astrophysics department gets in on the act. Some argue it's a dry comet, Some call it a bizarre asteroid, and some whisper it could be alien tech. NASA and ESA scramble through archives, wondering how many similar objects they might have missed. Statistically, there should be thousands passing through the solar system every few years, but they're small, faint, fast. You'd have to be lucky to catch one, and this time, humanity was lucky. The story of Oumuamua feels mythic. It's as if the cosmos threw us a message. You are not isolated. You're part of a galactic community of drifting remnants, each carrying the fingerprints of alien suns. You can almost hear the poetic echo of Carl Sagan murmuring that we are star stuff, and for once you believe it literally. But the longer you gaze, the more questions rise. Why was it accelerating ever so slightly as it left the solar system? Why didn't it outgas like a comet? What gave it that weird tumbling motion, like a bottle thrown with too much spin? And perhaps the most unsettling question, if this was our first visitor, how many have already come and gone, unseen? You glance back toward Earth. Its pale blue halo is already fading. The sun is a golden coin. Beyond, the galaxy stretches on. Hundreds of billions of stars, each with its own story, its own debris, its own potential wanderers. Somewhere in that great black quilt, another traveller is already en route. You pull your blanket closer, listening to the slow cosmic heartbeat of radiation and silence. The first visitor has passed, but it won't be the last. You're still floating there, somewhere beyond Mars now, half awake, half dreaming, as Earth turns into a pale marble behind you. The quiet hum of deep space feels heavier than silence. It's the sort of hush that makes you hear your own heartbeat echoing inside your skull. You tilt your head and notice how the stars don't twinkle out here. They just stare back. It's the perfect backdrop for a mystery. Back in 2017, the night Oumuamua was first noticed, things on Earth were far from peaceful. Astronomers weren't sipping tea and casually spotting interstellar debris. The Pan-STARRS system, those twin telescopes on the summit of Haleakala in Hawaii, was actually designed to scan for dangerous near-Earth objects, the kind that might someday ruin someone's day with a big dinosaur-ending kaboom. Instead, it caught history in motion, a small, dim point moving way too fast and from a direction that made no sense. Imagine being the first person to see it. You're sitting in front of a monitor glowing blue in the darkness. The software flags a faint object. Not remarkable at first, just another asteroid candidate. But when you plot its path against the background stars, your pulse jumps. The thing is inbound from above the plane of the solar system, at a steep angle no ordinary asteroid ever takes, and it's already leaving. You can almost smell the stale coffee as you hover ghost-like over the astronomer's shoulder, watching the cursor trace the orbit. There's that click of disbelief, then the low whistle that means something historic just happened. Within hours, word spreads through mailing lists and Slack channels. Object A/2017 U1. Check the orbital eccentricity. That number comes back greater than 1.0, the line in the sand that separates bound orbits from unbound trajectories. Translation: this object isn't coming back. It's an outsider, a drifter, a first-time tourist through our neighbourhood. Here's your historical fact for this section. The first recorded use of the word comet comes from ancient Greece, cometes, meaning long-haired star. People once believed those glowing streaks were divine messengers or omens of doom. In medieval Europe, entire armies turned superstitious under a comet's glare. Even 1066's Halley's Comet was said to foreshadow the Norman conquest. You grin a little at how old instincts die hard, because in a way that same sense of awe and dread rippled through astronomers when Oumuamua's data hit the community. They reclassified it quickly, first an asteroid, then a comet, then an interstellar object. The name changed as fast as the headlines. You imagine astronomers pacing between desks, mumbling orbital equations like half-remembered prayers. The object's brightness fluctuated so sharply that some thought it was tumbling chaotically, like a bottle thrown through space. Others suggested a more stable spin, but one that caused it to flash brighter when a broadside faced Earth. A quirky tidbit for you. One of the first follow-up observations was done with a 10-meter telescope on Mauna Kea, but the observer had to fight not clouds, not weather, but a laser guide star system from another telescope pointing too close to the same patch of sky. Only in astronomy could you lose a chance to study an interstellar visitor, because your neighbour's laser ruined your exposure. Somewhere, there's a frustrated grad student still telling that story at conferences. For a few days, the object was bright enough to study in detail. Spectra showed a reddish tint like old rust or dried blood, evidence of long exposure to cosmic rays. Its size? Somewhere between 100 and 400 meters long, depending on its reflectivity. You watch from your invisible vantage point as software models draw ellipses through the blackness, tracing its arc past the sun. The math whispers that it came from the general direction of the Lyra constellation, though pinpointing an exact star is impossible. Over millions of years, even stars wander. The trail blurs into statistical fog. Historians still argue whether the discovery moment itself, the night of October 19, 2017, should count as the dawn of interstellar archaeology. Before then, humanity's cosmic reach was limited to meteorites and samples brought home from the moon. Now, for the first time, we were studying something from another solar system without leaving our own. It's like finding a message in a bottle washed up on your cosmic beach. You drift closer, following the dream trail of data packets as they bounce between observatories. For weeks, telescopes around the world chase the faint visitor. Even the mighty Hubble Space Telescope turns its gaze, catching Oumuamua as a pinprick among galaxies. Each observation adds a puzzle piece, but none fits quite right. Its trajectory curves slightly, faster than solar gravity alone can explain. The deviation is small but undeniable. That's when the whispers begin. Outgassing, radiation pressure, or cue dramatic sci-fi soundtrack, artificial propulsion. You roll your eyes fondly. Scientists love a good argument almost as much as they love data. Still, the alien probe theory refuses to die quietly. You can imagine late-night radio hosts and Reddit threads spinning tales of derelict starships and lost civilizations. The truth, as usual, hides in the grey spaces between wonder and math. As Oumuamua fades from view, you sense the collective sigh of the astronomical community. It was here for only a few weeks, too short to send a probe, too dim for a detailed image. All that remains is the data, the speculation, and that eerie feeling that something from another star once brushed past your world and didn't even stop to say hello. You feel that tug of melancholy again, the one that comes when you realize how brief cosmic encounters really are. But there's also excitement, because if we've seen one interstellar visitor, there must be more. Statistically, thousands of such wanderers pass unnoticed through the outer solar system every year, faint as dust motes in moonlight. All it takes is sharper eyes, faster computers, and a bit of luck to catch the next one. You glance back toward the sun. From here it's just another star, warm, bright, oblivious. Around it the planets spin in their ancient loops, none aware that they've just been brushed by something ancient and foreign. Somewhere far behind you, Oumuamua continues its silent spin, heading out toward Pegasus, a tiny relic of someone else's cosmic story. For now, the telescopes rest, but their lenses still face upward, hungry for the next flicker that doesn't belong. Because once you've glimpsed a stranger passing through your home, you never look at the sky the same way again. You drift with the data now, half embedded in a stream of numbers and light curves as if your mind has become part of a telescope. The first interstellar object hums through your dreams, and you chase it, not with rockets, but with curiosity. Every decimal point becomes a breadcrumb, every equation a trail in the dust of space. Oumuamua doesn't care about your fascination. It doesn't slow down or even flicker politely for the cameras. It just glides, indifferent through the sun's light, and keeps going. You feel like a paparazzo trying to photograph a celebrity sprinting through the dark at 196,000 miles per hour. That's roughly how fast it's moving. So fast it crossed the inner solar system in mere weeks. It came in from above the plane of the planets, swooped around the sun, and slingshotted out again toward the constellation Pegasus. From your floating vantage, you watch its path like a looping comet that missed its chance to glow. If you could freeze time, you'd see that its trajectory was hyperbolic, meaning its orbit isn't a neat ellipse like Earth's, but an open curve, a cosmic escape line. Once you're on a hyperbolic trajectory, there's no coming back. Oumuamua is the celestial equivalent of a road tripper who forgot to buy a return ticket. Here's your historical anchor. Back in 1687, Isaac Newton published his Principia Mathematica, where he first described how every planet's motion followed the pull of gravity, forming predictable ellipses. He even accounted for parabolas and hyperbolas, the escape routes for bodies moving too fast. But even Newton probably never imagined one of those theoretical paths would, centuries later, belong to an actual visitor from another star. Astronomers plug Oumuamua's numbers into their models and realize something unsettling. It didn't enter randomly. Statistically speaking, it's aligned with the local standard of rest, the average motion of stars in our region of the Milky Way. That means it's been coasting for eons, neither chasing nor fleeing the stellar crowd, just adrift in interstellar limbo. You can almost picture it. Centuries of silent flight passing through the invisible borders between star systems, gathering a coat of cosmic dust. Micrometeorites ping off its surface. Radiation bakes it until its minerals redden and carbonize. If it were once icy, its outer layers have long since evaporated, leaving a hardened shell, something halfway between a comet and an asteroid, a hybrid no one has ever seen before. And yet its movement isn't fully explained by gravity alone. That tiny extra acceleration is like a faint hand on its back. Some researchers think sunlight itself provides the push, exerting radiation pressure on its surface. That would make sense if Oumuamua were very thin, perhaps only millimeters thick like a sail. You can almost see it now, a vast, slow-turning sheet of cosmic foil drifting past the planets. Of course, others think that's a stretch. The Harvard duo Avi Loeb and Shmuel Bialy published a paper in 2018 suggesting the light sail idea wasn't crazy, and the media lost its collective mind. Headlines screamed about alien technology. Twitter was ablaze with memes of cigar-shaped starships and interstellar parking violations. Meanwhile, most astronomers quietly muttered that natural explanations were more likely. But secretly, a few of them probably wanted it to be real. Here's your quirky tidbit. One artist's rendering of Oumuamua, tall, sleek and dark like an obsidian popsicle, became so famous that people started mistaking it for an actual photo. Even NASA had to clarify that, no, we never saw it up close. Humanity's first portrait of an interstellar visitor is, in truth, a glorified doodle. Historians still argue whether Oumuamua's discovery marked the moment astronomy entered a new kind of storytelling, where data alone couldn't satisfy the human hunger for narrative. Science meets myth here, right at the boundary between probability and poetry. We didn't just find a rock, we found an enigma. You imagine being the object itself now, turning slowly in the sunlight, watching the bright disk of the sun shrink behind you. You're not metal, not alive, but you carry secrets older than the human species. Maybe you once circled a red dwarf star, maybe you were ejected when a giant planet migrated inward, flinging you out like a marble from a slingshot. You tumble for millions of years, your surface scarred by radiation until you're as hard as glass. Then, by pure coincidence, you pass through this young, noisy solar system filled with curious creatures who immediately panic and publish 20 papers about you. It's oddly charming, you think. Astronomers across the globe race to track it as it fades. The Spitzer Space Telescope tries to detect infrared heat from it, but gets nothing. That means it's small, very small, maybe no longer than a football field. That discovery tightens the mystery. Something that's small shouldn't have reflected so much sunlight unless it was unusually shiny or flat. You picture it spinning like a coin flicked in slow motion, sunlight flashing across its surface every few seconds. Its brightness curve looks almost rhythmic, hypnotic even. If you were watching it through a telescope yourself, it would blink faintly, on, off, like a heartbeat against the dark. There's something poetic about how quickly it vanishes. By January 2018, just 3 months after discovery, it's already beyond reach. The fastest spacecraft humans have ever built, the Voyagers, the Pioneers, couldn't catch it even if we'd launched immediately. By the time we truly understood what we were looking at, it was gone. You think about that a lot. The idea that the universe doesn't wait for us. Wonders appear, we blink, and they're gone. Oumuamua doesn't care about our deadlines or our curiosity. It reminds you that space is full of fleeting miracles we'll never quite hold on to. But it also leaves behind something valuable, a new lens through which to see the cosmos. Because once we realize interstellar visitors are possible, we start looking harder. We refine our software, upgrade our telescopes, plan new surveys. The next one won't escape so easily. As you drift through this thought, you can feel the shift from awe to anticipation. Humanity has spotted its first messenger from beyond, and you, in this dream of data and starlight, can sense that another is already on its way. a more traditional traveller, still icy and whole, carrying the scent of another sun on its frozen skin. But that's a story for a few sections from now. For now, Oumuamua continues its impossible path, spinning into eternity, silent and unknowable, a cosmic wink that says, "You noticed me. Finally." You wake, or rather you float, in the dark somewhere between Jupiter's orbit and forever. You're still following that strange shard, but your dream vision sharpens now, focusing on its shape, because no one on Earth can quite agree on what Oumuamua really looks like. In your hand, if you still had one, you turn an invisible model of it under a starlight that's millions of years old. When astronomers first tried to reconstruct its form from brightness changes, the numbers refused to behave. Sometimes it appeared long and narrow, like a space cigar. Other models suggested something more like a cosmic pancake, wide and thin. The truth wobbles somewhere between the two, like a rock that can't decide which side of physics to obey. You can almost hear the scientists arguing across time zones, waving their printouts at each other through glowing zoom windows. One group insists the brightness variation must mean it's stretched, maybe 10 times longer than it is wide. That would make it unlike anything else ever found in the solar system. But another team points out that the light curve could also fit a disc-like shape tumbling like a dropped plate. It's the astronomical version of the "is the dress blue or gold" argument, except the dress in question is hundreds of meters wide and several light minutes away. Here's a historical nugget for you. Back in 1986, when ESA's Giotto probe photographed Halley's comet up, close for the first time, scientists were shocked to find it wasn't round or icy white. It was dark, jagged, and blacker than coal. The entire image upended centuries of comet lore. Maybe, you think, Oumuamua is pulling the same trick, forcing us to admit that reality doesn't care what we expect. You glide closer, trying to focus on its outline. The surface glints faintly red, not from rust, but from radiation damage. Cosmic tanning at the galactic spar. If you could touch it, it might feel smooth and glassy in some places, rough in others, pitted with the scars of countless micrometeorite strikes. But no matter how long you stare, you can't find edges that make sense. It's as if your brain refuses to decide whether you're looking at something solid or a shadow masquerading as an object. Down below, telescopes gather more light curves, chasing the shape through math. The faint pulses of brightness come every 8 hours or so, suggesting a spin. Some analysts propose a tumbling non-principal rotation, a fancy way of saying it's wobbling drunkenly, not rotating smoothly around a single axis. You can't help but smile at that. Somewhere, a space rock is doing cartwheels past the planets, and all of humanity's finest minds are squinting at it like someone trying to read alien Morse code. A quirky tidbit. In a move that perfectly sums up modern science, one astronomer generated 60 million simulated light curves on a supercomputer to test which shape best fit the observations. The winning model? A thin, flat, vaguely pancake-like slab. But then another study argued that, given the same data, you could also model it as a cigar if you added reflective patches. It's the first time in scientific history where breakfast food and tobacco both served as legitimate geometric analogies. Historians still argue whether the obsession with its shape was more science or psychology. After all, no one had seen anything like it before, and the human mind hates uncertainty. A long, cigar-shaped object feels familiar. It echoes our technology: rockets, ships, probes. But a disk? That stirs other associations: UFOs, saucers, conspiracies whispered in neon-lit diners. Each team of scientists, perhaps unknowingly, was projecting its own imagination onto the same invisible shadow. You drift backward now, far enough to see the whole solar system, a delicate clockwork of light and motion. Oumuamua's path slices through like a graffiti line sprayed across a painting, utterly indifferent to the symmetry. You wonder if it knows it's strange. Of course, it doesn't know anything. It's just inertia wrapped in mystery. Still, there's a kind of poetry in that ignorance, a freedom from all the questions we keep throwing at it. If it were long and thin, maybe that shape helped it survive the violent ejection from its home star system. Debris collisions, gravitational pinball with giant planets, the chaos of formation, it would have been tossed like a twig in a hurricane. Over millions of years, only the most durable shapes endure. Or maybe, if it's flat, the thinness helped it sail gently through interstellar gas, preserving it from erosion. Either way, its geometry is its biography. You drift alongside, noting how sunlight plays across the surface. As it spins, you see flashes of bright and dark, like a cosmic strobe light. Each flash is a tiny window into its material, ice crystals catching the light here, carbon dust muting it there. You realize the shape might not even matter as much as the texture, the way it reflects or absorbs. It could be porous, spongy, fractured, less like a rock and more like a loosely bound pile of rubble. That would explain its lightness, its subtle acceleration as sunlight nudges it onward. Your thoughts stretch back to all the things humanity once thought it understood. Planets as perfect spheres, comets as omens, the edge of the galaxy as unreachable. Every discovery bends the story a little more. Oumuamua's shape debate isn't just about geometry, it's about humility. The universe keeps reminding us that our definitions are temporary. You imagine an alien civilization somewhere far away watching their own fragment drift into the night, unaware it will someday pass through another star system. Maybe they're arguing about its shape too, pointing at blurry telescope images and saying, "It looks like a donut," while their alien graduate students sigh dramatically. There's comfort in that symmetry. Curiosity, after all, might be universal. Back on Earth, the news cycle moves on. Space doesn't hold its headlines for long, but in observatories and data archives, Oumuamua lingers. Every few months a new analysis appears, someone reprocessing the numbers, someone suggesting the rotation rate was different, the composition odd, the origin untraceable. It's a slow-burning mystery, the kind that doesn't fade with distance. From your vantage point in the dark, you can see both the rock and the ripple it left in human imagination. One small shape, whatever it may be, has tilted how we see the cosmos. We're no longer just inhabitants of the solar system, we're gatekeepers on a galactic thoroughfare. The object drifts on, indifferent to your fascination. Long or flat, real or mythic, it remains the same, a fleeting visitor, flashing once in your sky before the endless black swallows it whole. You're still tumbling beside Oumuamua now, caught in its silent spin. The stars whirl like pinpricks of silver thread, and the sun flashes behind you every few seconds as the object rotates. You can almost feel the subtle tug of light itself, the invisible pressure of photons nudging the rock ever so slightly off course. It's faint, but it's real. You sense the universe breathing on a pebble. Back on Earth, astronomers are doing math so precise it makes your temples ache. They've noticed that as Oumuamua leaves the inner solar system, it's accelerating just a little more than gravity predicts. Not much, maybe a few millimeters per second squared, but enough to set the astrophysics community ablaze. You hover like an eavesdropper in the data streams, listening to the murmured theories spill out across the world. The simplest idea? Outgassing. That's what comets do. Sunlight hits them, ice is sublimate, jets of vapor push them slightly. But there's a catch. Oumuamua never grew a tail. No coma, no visible emissions, nothing that looked remotely like the misty plumes we expect. It moved like a comet but looked like an asteroid. It's the cosmic equivalent of someone saying, "I don't like drama," and then moving through your life with mysterious momentum anyway. Here's a historical detour. In 1950, the Dutch astronomer Jan Oort theorized a vast cloud of icy bodies surrounding the solar system, the Oort cloud. He suggested that comets we see are just visitors from its frozen edge, knocked inward by gravitational nudges. Oort's theory was revolutionary because it explained comets' unpredictable arrivals. Now, 7 decades later, astronomers faced a similar leap, except this time, the object wasn't from our own cloud, it was from someone else's. The outgassing explanation starts to wobble. For one thing, sublimation strong enough to cause Oumuamua's acceleration should have produced visible dust. Telescopes saw none, and its spin didn't slow down, as it should have if gas jets were unevenly pushing it. That leads to the next contender, radiation pressure. The gentle force of sunlight itself could account for the observed acceleration, but only if the object was extremely thin, maybe less than a millimeter thick. You grin, because that brings you back to the now infamous light sail theory. Imagine something like a cosmic wafer, a broad, mirror-like sheet that rides the sunlight the way a sailboat rides the wind. That idea sounds like science fiction, but the math works frighteningly well. The problem is, nature doesn't make thin, perfectly reflective sheets. Not easily anyway. So where did it come from? Cue the academic fireworks. In late 2018, Harvard's Avi Loeb publishes a paper saying, "Hey, maybe it's artificial." The internet loses its collective composure. Reporters swarm, podcast hosts salivate. Half the scientific community groans audibly, and the other half secretly whispers, "But what if?" You can almost hear the sighs reverberating through observatories as graduate students are suddenly expected to answer questions about aliens during coffee breaks. A quirky tidbit for you. That same year, when journalists asked Loeb if he genuinely believed in an extraterrestrial explanation, he said he simply didn't want to rule it out. His exact words, "Extraordinary claims require extraordinary evidence, but extraordinary evidence requires open minds." It's the kind of quote that belongs both in a textbook and on a motivational poster in an underfunded physics department. Historians still argue whether that light sail hypothesis hurt or helped astronomy's credibility. Some claim it distracted the public with sensationalism. Others say it reignited passion for the unknown. What's certain is that it changed the conversation. Suddenly, serious journals were publishing papers about non-gravitational accelerations and photonic pressure, and late-night comedians were cracking jokes about alien frisbees. Science and culture had briefly collided in orbit. You follow the theory deeper. If Oumuamua were a light sail, maybe it wasn't designed for travel at all. Maybe it's debris, a fragment of a broken probe, a relic from a long-dead civilization, now coasting forever between stars. The idea is melancholy and majestic at once. Space junk, yes, but alien space junk. You imagine some distant species watching its lost artifact drift away and wondering, just as we do now, whether anyone out there will notice. But your rational mind nudges you. Maybe there's a simpler story. Perhaps Oumuamua is a nitrogen iceberg, a chunk shaved off the surface of a Pluto-like planet when a collision hurled it into interstellar space. As it passed the Sun, nitrogen sublimated invisibly. No dust, no tail, but enough thrust to tweak its course. A plausible theory, and less flashy than Alien Probe, though you suspect it'll get fewer clicks on YouTube thumbnails. You can almost hear the arguments echoing across the years. Each theory leaves a trail of data, rebuttals, and passionate footnotes. The only thing everyone agrees on? We need more examples. One interstellar visitor is an anomaly, two is a pattern. You float now, watching sunlight strike Oumuamua's surface. Each photon is like a microscopic hammer, hitting with a force too small to feel, but too consistent to ignore. It's poetic. Even light, the gentlest thing, can move mountains given enough time and emptiness. That realization hits you somewhere deep in the chest. The universe doesn't need engines to create motion. It only needs imbalance. Every gust of light, every collision, every gravitational whisper changes trajectories forever. Even you, drifting through this stream of starlight, feel yourself being pulled subtly toward the next story, the next wanderer, the next question. Oumuamua shrinks into the distance now, but its mystery keeps pulling your thoughts forward. Behind you lies a planet full of humans still debating its secrets. Ahead of you, space yawns open, filled with unseen travelers yet to arrive. You can almost sense one of them already inbound, a real comet this time, blazing and blue, making its own way toward the warmth of the sun. For now, you let the thought linger. The light that moves stones also moves minds. And somewhere out there, the same sunlight touching your face is still pushing Oumuamua onward, forever leaving, forever teaching, forever not quite understood. You drift through the wake of Oumuamua's passing, still tracing the faint glimmer it left behind, a whisper of motion across the cosmic sea. The mystery lingers like a song half remembered. You start to feel a tug backward in time, the urge to understand how humans have always looked at wanderers in the sky and tried to make sense of them. Because this fascination isn't new. Every civilization that's ever tilted its head toward the heavens has done the same thing you're doing now, stared, wondered, and maybe panicked a little. Far below, in your mind's eye, ancient Earth rotates. You see Babylonian priests on high terraces tracking bright streaks across the dawn. They called them Shumatu, brush stars, believing they swept evil from the heavens, or sometimes brought it down. The Greeks later named them comets, long-haired ones, imagining celestial maidens or torches carried by angry gods. You hover there invisibly, watching these early sky watchers mark each passing comet on clay tablets, their hearts pounding because every new light in the sky meant something. Here's your mainstream historical fact. In 44 BCE, when Julius Caesar was assassinated, a bright comet appeared during his funeral games. The Romans took it as a sign of his divinity, Caesar's comet they called it, and minted coins bearing its blazing tail. Even now, historians point out that the propaganda worked. The heavens had literally endorsed an emperor. You glide through time, skipping centuries like stones on a dark lake. You pause in medieval Europe, where people huddle under smoky skies as another comet ignites above them. To them, the sky isn't a clockwork machine yet. It's an emotional weather system. A new light up there means sickness, war, the wrath of God. Halley's comet in 1066 appears like a torch over England, and scribes record the people's terror, a portent of the fall of kings. Months later, the Battle of Hastings proves them right. You can't help but smile. Even now, thousands of years later, we haven't completely lost that instinct. Every time something new crosses the night, Oumuamua, Borisov, ATLAS, our first question isn't always scientific. Sometimes it's existential. Why is it here? What does it mean? A quirky tidbit for you. In ancient China, imperial astronomers had an entire taxonomy for comets, based on tail shape. Broom stars, feather stars, serpent stars. A broom star with its bristled tail was considered the worst omen, sweeping away dynasties. One surviving record describes officials trembling as they reported a sighting to the emperor. Careful to phrase it gently. No one wanted to be blamed for a bad comet. Historians still argue whether humans ever truly believed comets caused misfortune, or whether rulers just used them as convenient cosmic scapegoats. After all, when the sky itself announces your downfall, it's hard to argue with the PR. You float through Renaissance Europe next, where the story shifts. Tycho Brahe, the gold-nosed astronomer of Denmark, tracks a great comet in 1577. With careful measurements, he proves it moves beyond the moon, shattering the old belief that comets were atmospheric vapours. The heavens, it turns out, aren't perfect and unchanging. They're full of visitors. You feel the ground of human certainty crumble just a little, and a door creaks open, the door to modern science. That same door, centuries later, is the one Oumuamua quietly drifted through. The same sense of awe and disbelief that shook Tycho's observatory in the 1500s ripples through our telescopes today. Humanity has always reacted to new celestial arrivals the same way. Awe first, explanation later. You hover now over the 17th century, watching Isaac Newton and Edmund Halley scribble furiously by candlelight. Halley, using Newton's laws, predicts that a comet seen in 1682 will return every 76 years. When it does, he'll already be dead, but his name will live forever. That first accurate comet prediction changes everything. The universe starts to look a little less like a divine stage and more like a mechanical system, a cosmic clock ticking with mathematical precision. And yet, even with all that science, the fear and wonder never really go away. You jump to 1910. Halley's comet swings by again, and newspapers claim its tail contains cyanogen gas that could poison Earth. People panic, buy comet pills, seal their windows, and pray. You can't make this up. A few enterprising conmen even sell comet-proof umbrellas. Humans, you realise, will always find a way to monetize cosmic anxiety. By the time you return to the present, Oumuamua's age, something has changed but also hasn't. The awe is still there, but now it's filtered through data visualization and simulation models instead of prophecy. The telescope replaces the temple, but the feeling in the gut, the same. You, sitting at home scrolling through news about a cigar-shaped interstellar visitor, feel the same shiver your ancestors felt when fire-tailed omens swept their skies. You tilt your head, listening. Somewhere in that ancient echo is a lesson. The sky has always been both a mirror and a messenger. Oumuamua's arrival didn't just rewrite astronomy textbooks, it reawakened that primal awe humanity had tried so hard to outgrow. The stars above you shimmer as you think of all the stories humans have attached to comets. God's tears, dragon's breath, cosmic messengers, alien scouts. Maybe they were all right, in their own poetic way. Every visitor is a message, even if the sender is chaos itself. You watch as Oumuamua slips further from the sun, carrying not omens but questions. Somewhere far behind, the telescopes rest. Their operators sip lukewarm coffee and argue over whether radiation pressure or light sail fits the data better. And somewhere, in a different future, another faint light will appear in another telescope's image, and the cycle will start again. Maybe that's what the universe does best, recycle wonder. For now, you let your eyes close and drift with the thought. From Babylon to Hubble, The human heart hasn't changed much. Every strange light in the sky still makes us look up, still makes us whisper, "What if?" You float in the stillness after wonder, letting the afterimage of Oumuamua fade into the black. Behind you stretches humanity's long history of skywatching, and before you lies the machinery of our modern obsession. The telescopes, the code, the sleepless grad students with energy drinks and cosmic ambitions. Because once you glimpse a stranger in the dark, you start wanting another. The hunt begins. Below, on the slopes of Hawaii's volcanoes, the observatories gleam like glass-eyed giants. The Pan-STARRS survey, which first spotted Oumuamua, keeps sweeping the heavens in overlapping arcs. It was never meant to find visitors from beyond. It was built for planetary defense, a kind of early warning system against rocks that might one day ruin Tuesday. But after that fateful night in 2017, every telescope from Chile to the Canary Islands upgraded its vigilance. Somewhere in the endless data flood, astronomers whisper, another wanderer is waiting. You drift through the digital ether, watching rows of computers churn through thousands of nightly images. Each frame is a confetti storm of dots. Most are stars, fixed and steady. A few move slowly, asteroids, comets, bits of satellite junk. Algorithms scan for motion that doesn't fit the usual patterns. You hover over one researcher's shoulder as they code a new filter. Find anything hyperbolic. A simple phrase, but it's the birth of a new science, interstellar object detection. Here's your historical fact. In 1998, before any interstellar visitor was confirmed, a few bold astronomers used mathematical models to predict they must exist. They calculated that the Milky Way should eject trillions of icy bodies from newborn planetary systems, each wandering freely between stars. But no telescope then was sensitive enough to catch one. For almost 20 years, those predictions gathered dust, until Oumuamua vindicated them overnight. Now funding agencies perk up, new projects appear on whiteboards. The Vera C. Rubin Observatory in Chile, still under construction in your dream, promises to scan the entire southern sky every few nights. Its massive LSST camera will detect objects 1,000 times fainter than those Pan-STARRS could find. Astronomers joke that Rubin will see everything that moves. You imagine it like a giant cosmic security camera, forever watching for guests who don't belong. A quirky tidbit floats by. After Oumuamua, NASA quietly considered a mission concept called Project Lyra, a hypothetical spacecraft fast enough to chase the interstellar object before it escaped entirely. The plan involved gravity assists, solar sails, and a lot of wishful equations. It never left the drawing board, but it sparked something more valuable, a sense that we could, someday, intercept one of these travelers. Humanity, in other words, has begun making dinner plans for the next cosmic visitor. Historians still argue whether this moment, the years between Oumuamua and the next discovery, marks the dawn of a new field or just a temporary fascination. Some call it the interstellar object era. Others say it's a statistical fluke. Either way, telescopes keep staring upward like expectant fans at a concert, waiting for the next note to drop. You float beside those observatories as night rolls over the planet. The air up here smells of ozone and frozen basalt. Inside, domes rotate with a mechanical purr, lenses gleaming like liquid. Everywhere you look, data hums through fiber optics toward giant databases. Astronomers sit in silence, faces lit by monitor glow, as the universe scrolls past line by line. And then, in your drifting vision, you see the chain of cause and effect stretching outward. How each discovery births new technology, and each new tool opens a wider sky. You recall that back in the 19th century, the first photographic plates turned astronomy from sketching to evidence. In the 20th, CCD sensors digitized the heavens. Now, in the 21st, it's algorithms, machine learning models that can spot anomalies faster than any human eye. The watchers have multiplied, yet the same old wonder persists. One researcher keeps a sticky note on their screen. What else is out there? Another whispers to a colleague that if we catch an interstellar comet early enough, maybe we could send a probe to meet it, taste its dust, test its chemistry, see what other suns are made of. It's a dream half scientific, half romantic, to shake hands with the galaxy. From your place in orbit, you can almost feel their anticipation. It hums through the radio waves bouncing off the stratosphere, through the fiber cables curling under oceans. The entire planet is, in a sense, holding its breath. Somewhere, Maybe tonight, another object might already be inbound. Small, icy, unseen. You drift farther out, letting Earth shrink below you. The moon passes silently beneath your feet. Beyond it lies a wide field of darkness, the place where new data is born. In that space, a single pixel of moving light could change everything. You think about how strange it is that curiosity itself might be humanity's most universal constant. We can't stop scanning the horizon, even when the horizon stretches across galaxies. You remember how ancient priests once watched for omens, and how modern astronomers now watch for data sets. The ritual hasn't changed, only the tools. You turn your head. A faint hum catches your ear, like static from a distant transmission. It's the sound of discovery approaching. Not yet visible, not yet confirmed, but you can feel it brushing against probability. The telescopes keep sweeping, and soon, one of them will catch the next visitor. You breathe, slow and steady, the way one does before something historic. Because in just a few months' worth of cosmic time, another point of light will appear. It will look ordinary at first, like all the others, but its orbit will betray it, and when that happens, the hunt will end, and the story will begin again. The next messenger is already on its way. The night has stretched long, and the static hum of stars feels like a heartbeat in the dark. You hover somewhere above Earth, watching the slow dance of telescopes and satellites, when suddenly a new flicker appears on the radar of human attention. It's December 2019, and the world below is turning toward chaos of its own making. But in the background, a different kind of headline quietly forms. A new visitor has entered the solar system. This one isn't subtle. It doesn't play coy the way Oumuamua did, flickering and vanishing before anyone could get a good look. No, this one glows. A proper comet with a tail and everything. It's not shy, and for once, astronomers can breathe easy. The announcement comes from a Ukrainian amateur astronomer named Gennady Borisov, who spent his nights scanning the sky with a homemade telescope in Crimea. That's right, homemade. You can't help but grin. Humanity's first clear interstellar comet was discovered by one person, tinkering in his backyard, building his own glass and metal time machine. You drift down, hovering over his small observatory as his dome creaks open. The sky stretches over him like an endless slate, and there it is. A faint smudge of light moving against the background stars. He logs it, cross-checks it, and soon the alert pings through the astronomy networks. The world's great telescopes pivot their eyes toward his patch of sky, and within days, confirmation comes. Comet 2 I/Borisov, the second known interstellar object, is real. You exhale in awe, as though the cosmos has answered humanity's call with a smile. Here's your historical fact. Back in 1995, when Comet Hale-Bopp appeared, it became one of the brightest comets of the century, visible to the naked eye for 18 months straight. Millions watched it streak across the sky, and though it was bound to the sun, it inspired the same kind of cultural ripple you're seeing now, proof that people still look up, even in an age of screens. Borisov's discovery doesn't light up the world like that, but in the hearts of astronomers it burns even brighter. Because this one came from the stars. You drift close to Borisov's faint tail, weaving through its icy breath. Unlike Oumuamua's sleek ambiguity, this visitor is almost comforting in its familiarity. It's comet-shaped, a classic, an icy nucleus spewing vapor as sunlight heats it. Its coma glows with cyanide and carbon chains. Its tail unfurls in a soft arc like gauze. This is no cosmic UFO. This is a snowball with an interstellar passport. You can almost hear astronomers sighing with relief. Finally, a stranger we can understand. Still, even this familiarity hides strangeness. Its speed, 32 kilometers per second relative to the Sun, marks it as unbound. Its orbit, hyperbolic and steep, cuts across the plane of the planets like a skipping stone. And when its composition data starts to arrive, things get interesting. It's rich in carbon monoxide, far more than typical comets from our Oort cloud. That suggests it formed in a much colder place, maybe on the outer edge of another star system, somewhere the sunlight never reached. A quirky tidbit. Scientists discovered that Borisov's coma contained traces of hydrogen cyanide, the same molecule that, in the right conditions, can form amino acids. It's the kind of chemical we associate with the beginnings of life. For a few weeks, the internet buzzed with headlines. interstellar comet carries building blocks of biology. You can almost see the smirk on the universe's face, always dangling mysteries just close enough to make us wonder. Historians still argue whether Borisov's timing was pure coincidence or poetic symmetry. After Oumuamua's mysterious visit in 2017, some believed we might not see another interstellar object for centuries. Then, barely 2 years later, here came Borisov, glowing, textbook, undeniable. Some call it statistical luck, others cosmic generosity. Whatever it is, it's enough to ignite a movement. Back on Earth, observatories queue for time slots. The Hubble Space Telescope, the ALMA Array, even the European Southern Observatory all take turns watching Borisov. For once, the scientific community moves in harmony, sharing data freely, united by wonder instead of competition. It's rare, and it's beautiful. You hover above them, a ghost in the circuitry, listening to the chatter. It's smaller than expected. Composition matches cold protoplanetary disks. It's evaporating fast. Get more spectra before it's gone. And beneath the chatter, an emotion hums. Gratitude. Because this time, they have enough warning to see. Borisov passes close to the Sun in late 2019, glowing faintly blue-green, the colour of its chemical heart. You can almost smell the sublimating ices, cold, metallic, and sweet. Unlike Oumuamua, which gave us questions, Borisov gives us context. It's proof that the galaxy is littered with planetary crumbs, flung outward during star formation, wandering forever until they stumble into another system like this one. You realise suddenly that your solar system isn't isolated at all. It's part of a great cosmic exchange network, trading dust and water and carbon like postcards between neighbours who never meet. Here's another strange moment. When Borisov nears its closest approach to the Sun, telescopes record small, flickering outbursts from its nucleus, like hiccups of vapour. Each outburst throws glittering dust into space. You drift through it, the grains sparkling around you like frozen confetti. Somewhere, a scientist at Caltech runs a simulation of the debris trail, calculating how long the fragments will linger in our system. The answer? Centuries. Even after Borisov itself is gone, tiny pieces of it will continue circling the Sun, faint relics of another world. You think about Gennady Borisov again, the man who first saw it. He doesn't have a NASA budget or a team of technicians. He just looked up patiently and noticed something odd. It's humbling to realise that, in an era of billion-dollar observatories, a single human with persistence can still rewrite astronomy. It makes you feel small in the best possible way. Somewhere far behind, Oumuamua continues to vanish into interstellar night, enigmatic, silent, unknowable. But Borisov at least left a trail of evidence, dust, data, chemistry, and the reassurance that the cosmos really does have neighbours. You feel your pulse slow as the comet glides away, its tail thinning, its nucleus fading into a tiny white spark. The Sun's light no longer warms it. Soon it will freeze again, perhaps for another billion years. You whisper a goodnight to it, though it can't hear. After all, it's travelled too far and too long to remember what warmth feels like. Still, you can't help but think that somewhere, someone in another star system is watching a similar comet, wondering if it too once visited another sun. The universe, it seems, is full of travellers, and you're lucky enough to have caught one in the act. You drift behind Borisov now, letting its faint turquoise tail trail across your field of vision like a slow-motion firework frozen in space. You can almost hear the hiss of sublimating ice, the quiet crackle of a body that hasn't felt sunlight in billions of years. Unlike Oumuamua, this visitor isn't coy, it's loud in its chemistry, shouting its origins molecule by molecule. You lean closer, if leaning were possible here, and watch the light scatter through its coma like powdered emeralds. From the very start, the data poured in. The first spectral lines revealed familiar fingerprints: water vapour, carbon monoxide, cyanide, dust. It smelled, figuratively speaking, like every other comet humans have ever studied, but the ratios were wrong. Too much CO, too little water. It was a recipe for ice forged in temperatures colder than anything in our solar system. You imagine its birthplace, a disk of gas and dust swirling around a dim red dwarf, somewhere a few dozen light years away, where sunlight was only a rumour. Here's your historical anchor. In 1959, astronomers at the McDonald Observatory detected hydroxyl radicals in Comet Halley's tail, confirming that comets were mostly water ice after all. That single discovery turned comets from dirty snowballs of mystery into understandable physical objects. Now, 60 years later, Borisov turns that neat definition back on its head. Maybe comets aren't universal. Maybe every star system bakes its own recipe. The chemistry teams go wild. Instruments in Chile, Spain and Hawaii triangulate readings. ALMA, the Atacama Large Millimeter/Submillimeter Array, detects HCN and CO in amounts 10 times higher than typical. The comet's ratio suggests it condensed in a region 20 to 30 Kelvin above absolute zero, so far from its parent star that nitrogen froze solid. You float in that imagined birthplace for a moment, watching newborn planets coalesce amid ribbons of ice. A violent encounter, a passing star or a migrating giant planet, flings this tiny frozen seed outward, and it spends eons drifting between suns until it finally blunders into ours. A quirky tidbit. When Borisov passed through the solar system, one astronomer joked that we'd finally gotten an interstellar health inspection. The idea stuck. Every molecule in its tail became a data point in a cosmic quality control report, letting scientists compare the ingredients of distant planetary systems. The verdict: our neighbourhood isn't special, just one kitchen among billions cooking with the same raw materials. Historians still argue whether Borisov's discovery deserves more fame than Oumuamua's. After all, it was easier to study and less controversial. No need for alien hypotheses, no debates about cigar versus pancake. But perhaps because it was normal, the media barely noticed. You picture poor Borisov, the introverted sibling who shows up to class on time and gets overshadowed by the mysterious older brother who may or may not be a vampire, not be an extraterrestrial probe. You move closer to its surface, tracing faint jets that fan outward as sunlight gnaws at its crust. Each vent spews tiny grains of rock and ice that glint like glitter. They look harmless from here, but travelling at 30 kilometers per second, they could slice through steel. You remember that even comets born in other systems play by the same physics: mass, motion, momentum. The math doesn't care which sun raised you. Meanwhile, researchers keep finding subtler oddities. Polarization measurements suggest its dust grains are unusually large and compact, more like gravel than powder. Maybe they've been fused by cosmic rays during their interstellar exile. That long exposure would also redden its surface, a tan earned from a billion-year vacation in radiation. You wonder if all wanderers come back sunburned. You drift alongside the comet as it arcs past perihelion. The sun blazes in the distance, and for a brief few days the entire nucleus glows brighter than a city seen from orbit. Hubble snaps images that resolve it into a soft core about a kilometre wide. Through the telescope's mirror eye, you glimpse faint striations, cracks, fault lines, maybe the beginnings of its breakup. Comets live fast and die messy. Back on Earth, scientists compare Borisov's spectra to every known comet catalogue. The similarities are comforting. It means that the chemistry of life, the carbon, the water, the nitrogen, aren't unique to our system. You think of that for a long time, the quiet implication that somewhere, on some other rocky world orbiting a different star, those same molecules might have combined, boiled, cooled, and wandered about the sky. But data alone can't capture the beauty of it. If you could touch the coma, it would feel like cool smoke. The sunlight refracts through microscopic crystals, creating halos of colour that no camera can fully capture. You drift through that cloud, letting the particles brush against your skin like dry snowflakes. For a moment, you feel connected, not just to Borisov, but to every world that ever was. And then the outbursts begin. As it swings past the sun, thermal stress cracks its surface. Plumes erupt, briefly doubling its brightness. Telescopes record each flare like a heartbeat. On December 8th of 2019, a particularly strong outburst throws off chunks the size of houses. The comet is literally shedding itself into our solar system, scattering a trail that Earth will never cross but that will linger for centuries. You watch those fragments spin away, tumbling into new orbits, smaller, dimmer, but eternal in their own quiet way. By early 2020, Borisov is already fading. Its tail thins, its core dims. In the data archives, light curves flatten into silence. Yet the numbers it left behind fill terabytes, chemical maps, orbital paths, dust densities, all of it a love letter from another star. Scientists begin to compile it into models, drawing family trees of alien planetary systems. Each variable, each measurement, whispers the same comforting truth. The galaxy recycles itself. You take one last look at Borisov as it drifts outward, now nothing more than a faint smear in a telescope's eye. Behind you, Earth turns, oblivious. Ahead lies the deep, where other wanderers wait their turn. You feel a strange peace in knowing that somewhere out there, more comets are already en route, messages written in ice, still unopened. You exhale and whisper into the void, a farewell that sounds more like gratitude. Because for all its chill and chemistry, Borisov's visit was warm with meaning, proof that we are not alone in the materials that make us. You're still drifting in Borisov's wake as its light dims, your thoughts scattered like the dust in its fading tail. What the data whispered, what it still whispers, feels like the echo of a faraway truth, one that doesn't shout but hums patiently in the background of existence. You follow that hum back toward Earth, to where telescopes digest the comet's story pixel by pixel. Borisov may be gone, but its fingerprints linger in every archive and algorithm. The chemistry, the trajectory, the dust. Each one tells a piece of a puzzle too big for any single person to solve. You drift invisibly through observatories again, between blinking servers and quiet coffee cups, as the scientists pore over the comet's spectral signatures. The graphs look like mountain ranges drawn in light, sharp peaks where molecules sang in infrared, valleys where they stayed silent. Here's your historical anchor. In 1904, a Scottish physicist named Sir James Jeans first proposed that stars could fling matter into space through gravitational tugs, seeding other systems with fragments. Back then, the idea seemed almost fanciful. How could a tiny object ever escape the pull of a star? A century later, Borisov's orbit proves it's not only possible, it's common. Every star in its youth throws tantrums that scatter rocks, ice, and maybe entire comets across interstellar distances. You picture it now, the galaxy as a restless ocean, each wave a planetary system tossing debris into the currents. But Borisov's data adds nuance. For all its similarities to our comets, it isn't a twin. It's a cousin from a colder, more carbon-heavy environment. Its nucleus is denser, its ice is purer. In that detail lies a quiet revelation. Planetary systems differ not just in layout, but in personality. Some make rocky planets, some endless gas giants, some just freeze their potential and hurl it outward. A quirky tidbit. While analysing Borisov's dust composition, scientists at the University of Maryland noticed that its grains were surprisingly uniform. Tiny, rounded pebbles of silicate, rather than the fluffy clumps typical of solar system comets. One researcher described it charmingly as interstellar beach sand. The nickname stuck. Somewhere in a data repository right now, there's a folder labelled beach_sand_spectra_final_v3. You can almost hear the quiet pride behind that name. Historians still argue whether Borisov's smooth textbook behaviour was a relief or a disappointment. On one hand, it proved that interstellar comets exist and are chemically comprehensible. On the other, it lacked the intrigue of Oumuamua's strangeness. Humans, you realise, are addicted to anomalies. We want the universe to surprise us, even when it already has. You hover near Hubble's mirror, catching its reflection as it stares into the dark after Borisov's retreat. Its final images show a faint, diffuse glow, evidence that the nucleus might have fragmented. Tiny shards drift behind it like breadcrumbs. The comet is dissolving into memory. But those crumbs aren't meaningless. They're data points, paths we can trace for decades. You follow one of them, a microscopic piece of frozen methane no larger than a sand grain, tumbling endlessly around the sun. It may orbit for centuries before sunlight vaporizes it completely. In that slow evaporation is a metaphor you can't quite shake. Every visitor leaves something behind. You float now above the human world again. In labs and conference halls, scientists trade papers with titles like Volatile Ratios in an Interstellar Comet and Implications for Exoplanetary Disk Composition. They argue about the models, tweak parameters, rerun simulations. You catch snippets of conversation that sound more like poetry than science. Too much cyanide to be typical? Dust albedo lower than expected? Maybe its parent star was metal poor. Each sentence, in its way, is a love letter to curiosity. The more they study Borisov, the clearer the picture becomes. It likely formed in the outer reaches of its native disk, beyond the frost line, where CO and N2 ices could solidify. That implies its home star was faint, perhaps an M dwarf, one of the most common stars in the galaxy. You imagine a small red sun surrounded by infant planets, one of which gets too close to a giant neighbour and slingshots Borisov outward. It's a cosmic exile, cast adrift before its world even fully formed. You drift beside the ghost of that system now, imagined from math and longing. You see the stormy pink clouds of its nebula, the clumps of rock forming embryonic moons. Somewhere, another Borisov waits, frozen and forgotten. You realise the universe must be littered with billions of them, each carrying its own story. Back in the present, the final analyses of Borisov's data reveal something quietly astonishing. Its ratio of dust to gas was unusually high, meaning it was shedding solid material faster than expected. Some scientists take that as a clue to its fragility. Perhaps it's not a pristine traveller from a cold system, but a relic already battered by time. That fragility, you think, mirrors us, bright for a moment, crumbling slowly under our own heat. A small smile touches your lips, because you can't resist a human thought. If Oumuamua was the mysterious stranger in a trench coat, Borisov was the friendly neighbour who brought cookies from another galaxy. Both taught us something vital, that visitors don't need to be extraterrestrial emissaries to change our perspective. Sometimes they just need to exist. You let the metaphor dissolve into silence and look out into the dark once more. Somewhere beyond Neptune's orbit, the dust Borisov left behind catches sunlight like faint smoke. You imagine future astronomers detecting those grains and smiling, realizing they're studying relics from another sun. The thought feels like a lullaby for the rational mind, science sung softly through the language of wonder. You close your eyes, or whatever you have for eyes in this dream, and let the glow fade. Borisov is gone now, slipping back into the deep, its voice fading into cosmic background noise. But the data remains, archived forever in servers and memory, whispering across time. We are not isolated, we are participants. And somewhere, just beyond the edge of detection, another visitor begins to move, a faint dot in a field of stars, faster, stranger, coming your way. You can feel it before you see it, the emptiness that follows a revelation. Borisov is gone now, out there beyond the planets, a cold ember in the dark. The astronomers pack up their telescopes and turn back to the slow work of passing graphs, and for a moment, the solar system feels lonely again. You float among that quiet, where even the radio signals sound tired. Still, nothing in space truly ends. The dust Borisov shed continues to orbit the sun like faint smoke. Each grain carries its parent's signature, a whisper of chemistry, a memory of another star. You pass through it, particles ticking softly against you like snowflakes. They drift endlessly, tiny emissaries that never knew the messages they carried. Back on Earth, the news cycle has moved on. A few think pieces, a couple of viral animations, and then silence. But in the small corners of academia, where coffee and curiosity coexist, the conversation doesn't stop. Astronomers meet in windowless conference rooms to argue about what Borisov really was. One side says it was a typical comet from a different nursery. No great mystery there. The other insists the ratios of carbon monoxide and water hint at a system colder and older than ours. You can't just hand-wave those numbers, one researcher mutters into a laptop microphone during a virtual symposium. You hover nearby, smiling. Scientists argue the way poets edit. They can't help themselves. Here's your mainstream historical anchor. In 1957, the launch of Sputnik 1 marked the first time humans placed an artificial object in orbit. For the first time, we made something that could wander through space, however briefly. It was our first handshake with the void. You think of that now because, in a way, Borisov's visit completes the symmetry. An object made by another sun passing by ours, a cosmic return of the favour. A quirky tidbit surfaces in your mind. When the European Southern Observatory released its composite images of Borisov, one press officer accidentally colour-balanced it too green. Overnight, social media decided the comet must be glowing with alien radioactivity. Proof of life, read one tweet. It took a full week of fact-checking to explain that, no, sometimes Photoshop just gets overexcited. The universe is strange enough without a filter. Historians still argue whether this brief era, the two-comet age of Oumuamua and Borisov, should be treated as a scientific revolution or a curiosity between grant cycles. You suspect future textbooks will side with the revolutionaries. The paradigm has shifted. Our solar system is porous. Stuff gets in, stuff gets out. We're not an island, we're a bus stop. You drift outward now, following Borisov's trail as it crosses Neptune's orbit. The sun has become just another bright star behind you. The comet's nucleus, once glowing, now spins silently, cracking as it freezes again. Somewhere within that fractured heart are atoms that were once part of a planet, then part of a comet, and now part of the interstellar medium. The universe recycles everything, even mysteries. Below, Earth's observatories continue their vigil. The Vera Rubin Observatory prepares for its first light. Engineers run calibration tests, aligning its giant 3.2 gigapixel camera. When it finally begins full sky scans, it will capture 30 terabytes of images each night, an ocean of data through which software will hunt for anomalies. You hover above it, hearing the whir of servos and the faint human laughter of anticipation. Somewhere in that future data stream lies another visitor, waiting to be noticed. But before that next discovery, the community takes a breath. A dozen new papers appear, each claiming to have deciphered Borisov's secrets. One argues its colour indicates unusually pure ices. Another claims its dust grains were processed in a binary star system. A third suggests its volatile chemistry implies a brief but violent formation period. You watch the arguments spiral out like its tail. Beautiful, chaotic, all of them partially true. In quieter corners, the more philosophical astronomers ask different questions. If interstellar comets travel so freely, could microbes hitch rides between systems? Could the seeds of life leapfrog from one sun to another, carried on icy fragments like Borisov? The idea isn't new. Panspermia, as it's called, dates back to the ancient Greeks and was revived in the 20th century by scientists like Fred Hoyle. Still, with Borisov's sample of alien ice in our backyard, the theory suddenly feels less abstract. You hover over a small lab where a researcher examines a meteorite fragment under a microscope. Maybe, she murmurs, we've already been touched by dust from another system. You glance closer, seeing the carbon traces, the intricate lattices of minerals. Every rock, every mote of stardust could be a fragment of someone else's history. The thought makes your pulse slow and your mind go quiet. Outside, the night widens. Borisov's ghost trail stretches toward the Oort cloud, where the sun's gravity fades into the galaxies. You follow it until the stars blur together, and then you stop. Ahead lies nothing but potential. The raw possibility that somewhere out there countless other travelers are on their way, invisible for now but real. Before you turn back, you look once more at the faint path behind you. Two interstellar visitors, years apart, have rewritten everything you thought you knew about home. It's a sobering realization. The solar system isn't a sealed jar, it's a crossroads. You breathe out slowly. The air here tastes of cold dust and quiet revelation. The next chapter is waiting, but for now, you let yourself drift. The data hums softly, like a lullaby in binary. Somewhere, the galaxy keeps moving, and in that motion is promise. Because the long goodbye of Borisov isn't really an ending, it's the pause before the next knock on the door. Silence stretches after Borisov's fading light. It's a rich silence, the kind that feels full rather than empty. You're floating somewhere beyond Neptune's cold orbit now, your thoughts in sync with the hum of the cosmic background. The sun is only a soft coin behind you. Around its edges glimmer the faint threads of the Oort cloud, that borderland between us and everything else. The last of Borisov's dust mingles here with our own ancient comets, blurring the line between what belongs and what visits. You linger because this is where the story slows. Between one interstellar messenger and the next lies this interval, the watchful quiet between breaths. The telescopes down on Earth call it survey downtime, but to you it feels like anticipation made visible. After Borisov's departure in early 2020, the astronomy world entered a kind of waiting room. Observatories kept scanning, of course. The software never sleeps. But everyone knew how rare those first two discoveries had been. 2 interstellar visitors in just 2 years. Statistically outrageous. Surely the universe wouldn't be that generous again so soon. Still, You know better than to underestimate the cosmos. Here's your historical anchor for this part of the drift. In 1846, astronomers Johann Galle and Urbain Le Verrier used pure mathematics to discover Neptune. They never saw it at first, only calculated where it had to be. That's the same patience astronomers must summon now. They watch the numbers, not the sky, hunting anomalies through equations. It's a new kind of stargazing. Eyes replaced by algorithms, intuition replaced by code. You dip through their digital constellations, endless lists of orbital elements, eccentricities, magnitudes. You can almost smell the coffee and the flicker of blue light from too many monitors. Every so often a student yells, "Wait, look at this one!" And for a heartbeat the world stops. But then the program flags it. Just another asteroid. The sky teases and retreats. A quirky tidbit floats into view. At one observatory in Chile, the technicians began a ritual. Every Friday at midnight after the last dataset uploaded, they'd play David Bowie's Starman through the control room speakers. Someone joked it was a cosmic summoning. You smile at the thought of scientists dancing under red warning lights, asking the stars politely to send another visitor. Historians still argue whether this lull between discoveries was a scientific pause or an emotional one. Some claim the community needed time to process what Oumuamua and Borisov had done to its understanding of planetary formation. Others think the lull simply revealed how impatient modern science has become. We expect a universe that performs on schedule, but the cosmos doesn't do deadlines. You drift closer to the sun again, tracing the slow spiral of human activity around it. The Parker Solar Probe loops near its surface, tasting solar wind. The James Webb Space Telescope peers outward at galaxies billions of light-years away, indifferent to local gossip. And across the world, the upcoming Vera Rubin Observatory prepares for its grand debut. You hover over its empty dome in Chile as engineers test its giant mirror. When it begins operations, it will survey the entire sky every 3 nights, so comprehensive that missing an interstellar visitor will be nearly impossible. In the meantime, astronomers improvise. Some scour old data archives for missed objects, hoping one slipped through unnoticed. A few claim to have found candidates, tiny, faint specks that might have come from beyond. But the orbits never quite fit. The truth remains stubbornly simple. The next confirmed interstellar visitor hasn't yet arrived. You float in that in-between space where waiting becomes its own kind of meditation. The stars drift past like slow fireworks. You remember the early sections of this dream, Oumuamua's enigma, Borisov's clarity, and realize this pauses the bridge between them and whatever comes next. Discovery is exciting, but anticipation is sacred. The solar system feels like a stage set after a performance. The lights dim, the dust still drifting in the spotlight, the audience holding its breath. The telescopes are the ushers, ready to swing open the doors for Act 3. Somewhere in your drifting, you catch a faint transmission. Scientists discussing 3I/ATLAS, an object that at first seems like a comet, faint but promising. You don't lean in yet. That story belongs to the future part of your journey. For now, you let the whisper fade. You tilt your head, listening to the hum of the galaxy itself. Statistically, there should be hundreds of interstellar objects within the solar system at any given time. Tiny, dark, invisible. Most never reflect enough sunlight to be seen. Some may burn up in the sun, others drift forever between Neptune and nothingness. They're there, unseen companions on our cosmic highway. You imagine them like silent fish swimming through a transparent sea. It's comforting in a strange way to know that we're never truly alone out here. Even when the sky seems still, traffic moves invisibly all around you. A faint breeze of solar particles brushes your face, if you still have a face in this dream, and you close your eyes. In the quiet between discoveries, you can hear the faint rhythm of planetary motion, like a slow metronome. Mercury clicks first, then Venus, Earth, Mars, Jupiter, each planet keeping its time. You realize how patient the universe truly is. You drift outward again, toward the cold, where the sun's light becomes fragile. Beyond Pluto's orbit, comets from the Oort cloud shimmer faintly as cosmic rays tickle their surfaces. Some will fall inward one day, brightening our skies for a moment before vaporizing. Others will remain eternal ghosts, orbiting nothing but memory. That's where you stay for now, among them, waiting. You feel the next story approaching like a heartbeat in the dark, but you don't rush it. Space doesn't do soon, it only does inevitable. So you breathe, letting the cosmic quiet fold around you. Somewhere in that stillness, the instruments hum and the stars keep secrets. The next visitor is already moving toward you, faint, elusive, but certain. You don't see it yet, but the sky does. The universe is taking a deep breath before whispering again. You wait in that stillness until the next flicker comes, just a pixel of motion at first, barely strong enough to tickle the software's anomaly filter. Somewhere in a data center in Hawaii, an algorithm beeps. A technician leans closer. The coordinates sit oddly among the routine asteroid alerts. It's May 2024, and the file name is ordinary enough, C/2024A3, Atlas. You smile. The universe never announces itself with drum rolls. For weeks, no one pays much attention. The Atlas survey churns out thousands of transient detections a night. But then the orbital calculations begin to misbehave. The numbers that should describe a lazy ellipse start hinting at a hyperbola. You drift down through the hum of the servers as the realization passes from one desk to another. Something is moving through the solar system again, and it's moving too fast to stay. At first they think it's a mismeasurement, maybe a calibration error, but after a few nights the pattern holds. 3I/ATLAS, the third interstellar object ever found. You feel the collective shiver of scientists around the globe. The long silence has broken. The cosmic door has opened again. You slide through the data as the numbers refine themselves. Its inbound velocity is staggering, over 70 kilometers per second relative to the Sun. Its path slices through the ecliptic like a thrown knife, steep and strange. You hover beside the orbit diagram projected on a researcher's monitor, a bright thread of blue crossing the golden loops of the planets. It looks less like an orbit and more like graffiti on the solar system's chalkboard. Here's your historical anchor. In 1983, astronomers first used the IRAS satellite to map the sky in infrared, discovering thousands of comets and asteroids invisible to optical telescopes. 40 years later, those same scanning techniques let ATLAS catch this newcomer. History repeats itself in higher resolution. The first follow-up observations come from Chile, then South Africa, then Spain. The comet appears faint. Too faint, perhaps, for how close it should be. Some astronomers joke that it's a ghost, a data mirage. But when spectra arrive, they confirm activity, traces of gas, maybe dust. Unlike Oumuamua's bare rock, 3I/ATLAS seems to breathe, yet not quite like a normal comet either. Its brightness flickers irregularly as though pieces of it are missing. You drift closer, into the dream simulation that every astronomer now runs on their screens. A dim nucleus spins lazily, venting thin plumes of vapor. Around it, a halo of debris glitters faintly. The model suggests a fragmenting body, maybe already half destroyed before discovery. You can almost feel the chill of sublimating ice brushing against your skin, tiny molecules that last saw sunlight around another star. A quirky tidbit. One early press release accidentally used a placeholder image from comet ATLASC/2019 Y4, a completely different object that broke apart years earlier. The internet promptly decided the new comet had already disintegrated in transit. It took days for astronomers to clarify politely that they hadn't lost it, yet. Historians still argue whether to call 3I/ATLAS the third confirmed interstellar visitor at all. Its orbit is so eccentric that some claim it might simply be a long-period comet, kicked into a hyperbola by planetary encounters. Others insist the velocity is too high, the trajectory too steep. The debate spills across conferences and Reddit threads alike. For the moment, consensus teeters, but curiosity doesn't wait for majority votes. You follow the object as it nears the Sun. In your dream, you see its tail stretch into a thin blue ribbon, fainter than Borisov's, but undeniably real. For a few days it brightens, a ghost lantern on the edge of detection. Then, just as suddenly, it fades. Observatories report fragmentation. The nucleus has likely shattered. Pieces scatter along the orbit like breadcrumbs of ice. You hover among them, tiny shards tumbling past like transparent leaves. Each one catches sunlight for a heartbeat before vanishing. You reach out to touch one, and it melts through your fingers. The scent is sharp: ozone, metal, and frost. Back on Earth, astronomers scramble to make sense of the loss. We barely met it, one sighs during a live stream. Another smiles. That's the tradition. They publish quick notes, brightness curves, velocity tables, a few spectral lines. Then the fragments drift too far, too faint to track. The third interstellar object becomes another ellipsis in the sky, another reminder that nothing this fast ever stays long. And yet, it leaves behind questions even sharper than its orbit. Why do all three interstellar visitors behave differently? One dry and flat, one icy and loud, one disintegrating on arrival. Maybe they're clues to how diverse other solar systems truly are. Maybe they're simply cosmic accidents. The uncertainty itself feels like a message. Expect variety. You drift farther out as 3I/ATLAS recedes, watching the broken comet fade into statistical background. The solar wind sweeps its dust into a diffuse smear, a new filament in the great spiral of interplanetary debris. Somewhere behind you, telescopes power down for the night, their operators rubbing their eyes, murmuring that maybe next time they'll catch one sooner. You close your eyes and listen to the fading static of its passage. The pattern is familiar now: arrival, confusion, wonder, loss. Each visitor plays the same melody in a different key. Together they form a quiet symphony of motion, the sound of a galaxy breathing through its travelers. When you finally look up again, the sky has already returned to silence. But you know better than to call it empty, because every silence in space is only a prelude. You float among the shards of 3I/ATLAS as they drift apart, pieces of glitter suspended in an invisible tide. The sun's light bends faintly around the fragments, scattering them into a haze of gold and blue. It's beautiful in a tragic sort of way, like a firework no one meant to light. You're watching the unmaking of something older than Earth, and even though you know it's just physics, ice meeting heat, cohesion losing to entropy, it still feels personal. Back home, the telescopes keep trying to track what's left, but each night the faint points that should mark the nucleus scatter further. The light curves flatten, then vanish. Within weeks, 3I/ATLAS has gone from the next great interstellar discovery to a statistical ghost. You hover in the data like a phantom among phantoms, watching the world quietly move on. When the press releases start, they sound almost apologetic. Disintegration probable. Remnant dust cloud. Observational follow-up impractical. Translation: we lost it. Some astronomers admit, a little sheepishly, that maybe they never fully had it to begin with. The comet that shouldn't be, a visitor already half dead before it reached us. It feels less like a guest and more like a message in a bottle that shattered on arrival. Here's your historical anchor. In 1973, astronomers watched comet Kohoutek approach with immense excitement. Early estimates suggested it would rival the brightness of the moon. Instead, it fizzled. Dim, disappointing, a cosmic no-show. The newspapers called it the comet of the century that wasn't. Now, half a century later, 3I/ATLAS becomes its interstellar echo, the disappointment that still manages to teach. Because even a failure in space is data, and data, in astronomy, is devotion. The first reports from the Hubble Space Telescope confirm what the ground-based observatories suspected. A TLAS had already begun breaking up long before its closest approach. Its nucleus wasn't solid. It was a loose pile of rubble held together by the gentlest whisper of gravity. The stress of solar heating was simply too much. You drift closer in your mind's eye, watching fissures spider across its surface, jets of gas bursting like sighs. One by one, the fractures widen until the comet unravels into dust and faint blue fog. A quirky tidbit. A researcher at the University of Maryland ran a simulation showing that if you could reassemble all those fragments, the comet would be roughly the size of a sports stadium. They joked in their presentation, the universe threw us a baseball, and it crumbled into glitter before the pitch reached home. The audience laughed softly, half humour, half heartbreak. Historians still argue whether 3I/ATLAS truly qualifies as a confirmed interstellar object. Some insist its trajectory could have been distorted by outgassing or observational uncertainty. Others hold firm that its inbound velocity, 70 km per second, far too fast for a solar native, makes the case undeniable. The arguments flicker in papers, in conferences, in Twitter threads that stretch long into the night. no one wins. The comet, now dust, has the final word: silence. You float through what's left of it, the debris field thin and shimmering. The sunlight turns each grain into a tiny prism, flashing rainbow light before fading again. For a moment, you imagine what these fragments might have seen before they arrived here. Alien skies, unfamiliar constellations, the soft radiation of a distant star. Maybe they orbited a planet once. Maybe they were scraped from a moon's surface in some long-ago collision. Each grain is a story, with the ending burned away. Somewhere far below, a child looks through a backyard telescope and sees nothing but darkness. They don't know that. Right where they're staring, a dust trail the size of continents is passing invisibly overhead. That's the irony of astronomy. Sometimes the most profound events leave no visible mark. Still, in laboratories, the story continues. Researchers plug the 3I/ATLAS data into models of planetary formation, tweaking parameters to account for its fragility. Perhaps they suggest interstellar comets are typically weak, loosely held together by frozen volatiles that crumble when warmed. If that's true, then most visitors like Atlas die before we ever see them, which means, this is the chilling part, interstellar traffic might be far heavier than we know. We're just bad at catching the survivors. You hover at the edge of that thought, feeling the enormity of it. The solar system isn't a quiet cul-de-sac. It's an intersection where debris from 1,000 different stars constantly crosses paths. Most of it we never notice. It burns up, evaporates, or sails by unseen. But it's there, whispering across the cosmic ocean. You look at what's left of ATLAS again. It's hard not to project emotion onto it, even though it's just ice and dust. It came so far, only to dissolve a few million kilometers from the sun. A brief appearance, a few months of fame, then gone. You think of all the human things that echo that same shape: ambition, love, life itself, bright arcs that always end in fading trails. The astronomers will catalogue it as they do all things: numbers, coordinates, residuals. Object lost due to fragmentation. But the poets among them, and there are always a few, will write that the third visitor arrived already dying, and that it taught us something about impermanence. You drift further back now, letting the dust wash past you in slow waves. Beyond the shimmering haze lies the empty dark again, waiting for the next faint streak. You realise that each of these interstellar travellers, in its own way, is a mirror. Oumuamua reflecting mystery, Borisov reflecting familiarity, Atlas reflecting fragility. Together they paint a portrait of the galaxy as both wild and intimate, filled with travellers who never stay but always leave their fingerprints behind. In the silence that follows, you can almost hear a faint ticking, like the universe turning a page. Somewhere, in a telescope yet to be built, the sensor waits, and the next traveller is already inbound. For now, the fragments of 3I/ATLAS drift outward, slowly mixing with our own dust, becoming part of the same endless swirl. You smile softly. The visitor that shouldn't have been has become part of home. You drift farther into the darkness that 3I/ATLAS left behind. A thin, glimmering veil of dust that catches the sunlight only when you look at it sideways. Each particle spins slowly, aimless and weightless, a remnant of something that was once whole. The emptiness feels heavier now, but also tender, as though the universe itself is catching its breath after another brief hello. Some of those fragments will never leave. The smallest grains, slowed by sunlight and solar wind, will spiral inward until they vanish in the heat of the sun. The larger ones will stretch outward, carried into new orbits, blending with the background population of comets, asteroids, and micrometeorites. In time, no one will be able to tell which dust came from home and which from beyond. You watch the great celestial mixing bowl swirl around you and realize that cosmic identity is, by nature, temporary. Scientists begin the post-mortem. The observations of 3I/ATLAS weren't long enough for comfort, only a few weeks of clean data before the object fragmented, but they're enough to feed speculation for years. Spectroscopy shows traces of oxygen-bearing molecules, faint water signatures, and maybe, just maybe, the spectral fingerprints of silicate dust. For something born in another solar system, it's astonishingly familiar. Here's your historical anchor. In 1986, when ESA's Giotto probe flew past Halley's Comet, it found that the supposedly pristine ice ball was coated in black organic tar. That encounter rewrote what we thought a comet could be. Not just frozen water, but complex chemistry wrapped in darkness. 4 decades later, 3I/ATLAS whispers the same message from beyond our neighbourhood. Wherever comets form, they build with the same ingredients. A quirky tidbit. One graduate student analysing ATLAS's spectra used machine learning to compare it with all known comets. Their algorithm confidently declared 97% similarity to Comet Encke, one of the oldest periodic comets orbiting our Sun. So either it's interstellar, or Encke's cousin went on a really long vacation, they joked in a seminar. The laughter barely masked the awe. Historians still argue whether these interstellar comets, Oumuamua, Borisov, ATLAS, should make us rethink the definition of a solar system. Are these systems really boundaries, or are they just temporary eddies in a much larger galactic current? Maybe every star's debris becomes another's visitor eventually. Maybe the Milky Way is one vast network of exchanged matter, a cosmic marketplace trading minerals, molecules, and the raw materials of life. You float inside that metaphor and feel it resonate in your bones. The Milky Way isn't still. It's an organism, pulsing with exchange. Planets form, break, and scatter their remains, and those fragments wander until they seed the next generation of worlds. The atoms in your body could once have belonged to an alien ocean. Perhaps, long ago, a fragment like Atlas delivered the carbon that would someday become you. You pass through the comet's ghost trail again. Each particle here has a story it will never tell. The violent ejection from its home system, the centuries of frozen drifting, the brief, fatal encounter with our Sun. It's impossible not to anthropomorphize it, to see a kind of courage in its journey. You remind yourself it's just chemistry and inertia, but some part of you insists that even dust deserves empathy. Down below, in offices and observatories, researchers put the last touches on their reports. The official designation stands 3I/ATLAS C/2024A3, confirmed as the third known interstellar object. The press barely notices. No viral debates this time, no alien probe, headlines, just quiet satisfaction. It's as if the scientific world has learned a kind of humility. These visitors don't come to entertain us. They come to remind us how small we are and how vast the stories written in stone and ice can be. One astronomer compares ATLAS to a cosmic fossil record. Each layer of dust, each volatile trapped in its ices, encodes the history of another star's birth. If only we could touch one, they sigh. If only we could bring a piece back intact. You imagine it. Some future spacecraft swooping out of the inner system to catch an interstellar comet mid-flight, its robotic arm closing around an ancient relic. It feels like science fiction, but so did flight once. The possibility lingers, and so does the wonder. As you drift through the remnants, you notice how they shimmer faintly in solar light. From a distance, the entire trail looks like a ghost river flowing across the void. You imagine it from Earth. If only human eyes could see faint enough, it would appear as a thin ribbon of light, like a sigh stretched across the stars. You follow it for what feels like hours, days, maybe centuries. Out here, time has no texture. You think back to the pattern of all three visitors: the silent scout Oumuamua, the textbook traveller Borisov, the fragile ghost Atlas. Each one seemed to teach a lesson: mystery, familiarity, impermanence. Together they form a kind of cosmic trinity. You wonder if the next will complete a circle or break the pattern entirely. You reach the end of the dust trail where particles thin into nothing and glance back toward the Sun. The familiar planets loop around it, bright and predictable, unaware of the chaos that occasionally brushes their paths. The stillness feels deceptive. Even now, new wanderers are on their way, some already approaching, unseen, others ejected, heading outward to become someone else's visitor. You feel a strange peace, tinged with melancholy. Maybe 3I/ATLAS wasn't a failure after all. Maybe it was exactly what it was supposed to be, proof that even the broken things, the fleeting things, still count. The galaxy doesn't need permanence to make meaning, it only needs motion, and motion never stops. You turn away from the dying glitter, back toward the darkness where new lights will one day appear. Somewhere out there, beyond the reach of today's telescopes, another faint traveller is already moving in your direction. You can't see it yet, but you can feel its trajectory tugging faintly at the edge of probability. You smile and whisper into the dark, "See you soon." You float in the quiet wake left by ATLAS's fading dust, the sunlight thinning into amber threads around you. The solar system feels older tonight, its edges soft, its rhythms slow. You breathe in the stillness, half expecting the universe to speak, and in a way, it does. The whispers are mathematical, gravitational, chemical, soft syllables of physics that tell you how the next story begins. Because after 3 visitors, a pattern begins to form and humanity, ever curious, starts asking the next question. Where did they all come from? You tilt forward into that question, following it like a current. The answer lies far from here, in the nurseries of the stars, the vast disks of dust and gas where planets are born. You glide toward one, a simulation spinning before your eyes, a young sun glowing in amber fog, encircled by ribbons of rock and ice. Collisions flash like lightning, sending shards outward into the dark. Each explosion ejects material from the forming system, turning worlds in progress into catapults. The debris that escapes becomes the galaxy's driftwood, its interstellar travelers. Here's your historical anchor. In 1964, astrophysicist Viktor Safronov published The Evolution of the Protoplanetary Cloud, proposing that planets form through accretion. Dust clumping into pebbles, pebbles into boulders, boulders into worlds. What Safronov couldn't yet foresee was that this process doesn't just build, it expels. Each collision, each planetary migration, sends fragments hurtling into interstellar exile. Oumuamua, Borisov and Atlas weren't exceptions. They were the inevitable consequences of planetary adolescence. You drift through that imagined nebula now. You can smell the ozone of fresh starlight, the burnt sweetness of chemical reactions in the dust. Around you, tiny particles stick together and tear apart in an endless loop. One clump no larger than a city block survives the chaos, growing slowly. Then, an encounter. A newborn giant planet, hot and arrogant, tugs at it with gravity and flings it outward. You watch the fragment spiral away, its future sealed. It will never return. It becomes a wanderer. A quirky tidbit. A group of planetary scientists at Cambridge once simulated the ejection process for 10,000 virtual solar systems. Their conclusion? For every planet that survives, about 1 million smaller objects get thrown into interstellar space. Statistically speaking, the Milky Way should hold trillions of these exiles, drifting unseen. One of them, by sheer chance, passes through our skies every year or so. We've only seen 3, the rest slip by, invisible in the night. Historians still argue whether the formation of interstellar objects counts as creation or destruction. Some frame it as cosmic loss, bits of worlds unmade before they had the chance to shine. Others see it as necessary generosity, the galaxy sharing its raw materials among the stars. You find yourself liking that second view better. It feels less tragic and more communal. You drift past another simulated star system, this one binary, twin suns orbiting close. Their gravitational dance tears at their own debris disk, flinging ice and rock into chaos. You can almost hear the crackling chorus of collisions, the hiss of vaporized comets. Every star, it seems, leaves a wake of wanderers. You realize then that the galaxy is less a peaceful sea and more a turbulent storm, filled with projectiles from forgotten worlds. You turn back toward the sun, remembering the visitors that made you ask these questions. Oumuamua, perhaps a fragment of a shattered planet scorched smooth by radiation. Borisov, a traditional comet from a cold outer disk. Atlas, a fragile hybrid, its strength undone by heat. 3 different lives, 3 different homes, all sharing one fate, to travel forever. You feel the symmetry tightening like a thread. If every planetary system ejects material and every star inherits some from others, then everything in the Milky Way is connected. The water in your glass, the carbon in your breath, the dust under your feet. All of it might once have belonged to another sun. The galaxy isn't just a neighborhood. It's a family constantly swapping atoms. You drift closer to that realization until it feels warm in your chest. This isn't poetic exaggeration, it's literal physics. Meteorites found on Earth have already proven it. Tiny grains inside them show isotopic signatures that predate the solar system itself. Some of your atoms were born in other suns and wandered for billions of years before finding you. You are, in every measurable sense, interstellar. You let that thought sink in. The boundary between home and away dissolves. When Oumuamua entered the solar system, we called it a visitor, but perhaps we had it backward. Maybe we were the hosts only briefly, a small moment in its long, endless journey. In that perspective, ownership becomes meaningless. Everything is borrowed. Below you, the planetary systems keep building, breaking, scattering. In one, a comet's orbit collapses inward, feeding a forming ocean. In another, a moon is ripped apart, its fragments cast outward as new wanderers. You realize how cyclical it all is, the perpetual balancing of creation and loss. Nothing is static. Everything migrates. You think about how, in human terms, we've always mirrored this motion. Migration, exploration, exile. It's all the same pattern written smaller. We too fling ourselves into the unknown, hoping to find meaning or survival somewhere beyond. Perhaps that's why these interstellar objects resonate so deeply. They're physical metaphors for what we are. Restless, curious, impermanent. You glide through the galactic plane, stars streaming past like raindrops. You imagine all their invisible debris, comets, asteroids, planetary shards, crossing paths with one another in the dark. Occasionally one gets close enough to a new star to flare, and an intelligent species notices. That moment of recognition, one civilization realizing another's leftovers, feels profoundly intimate. The universe, it turns out, has been leaving us notes all along. You slow your drift, feeling the sun's distant gravity tug at you again. The lessons settle like dust. Everything moves, everything mixes, and even destruction makes beauty. Somewhere behind you, one of those ejected fragments is already curving toward our system. The instruments haven't spotted it yet, but probability guarantees its arrival. You smile faintly, whispering into the void, welcome in advance. Then you let yourself dissolve back into the galaxy's current, another traveller among trillions, carried by the same forces that shape stars, planets, and comets alike. Motion is the only permanence the universe offers, and you surrender to it completely. You surrender to that current of motion, letting it carry you deeper into the story of creation. The galaxy's spiral arms stretch around you like rivers of light, and every droplet in those rivers, every comet, asteroid, fragment, is a message written in minerals and memory. You drift between them as if reading the sentences of a cosmic diary. Now that you understand where interstellar objects come from, the next question unfolds naturally. How do they form? What cosmic recipe makes a wanderer? You let the scene materialize in front of you, a protoplanetary disk young and fierce. A star has just ignited at the center, a boiling sphere of fusion wrapped in a swirling skirt of dust. You hover above that disk, watching the chemistry of creation. Silicates and ices collide in slow motion, clumping together, breaking apart, then clumping again. This is the first heartbeat of a world. At the outer edge, frost lines glitter like pale boundaries between heat and cold. Inside those lines, metal and rock dominate. Beyond them, ice reigns. The two regions together form the raw ingredients for everything a star might ever produce. Planets, moons, and, when gravity grows careless, debris. Here's your historical anchor. In 2005, the Spitzer Space Telescope captured infrared images of a young star called HL Tau, surrounded by concentric gaps in its disk, each gap carved by a newborn planet. It was the first time humanity had seen planetary formation happening. You can imagine the quiet awe in the control room, the realization that these dusty spirals weren't abstract. They were the blueprint of every world that ever existed, including your own. You drift closer, tracing one of those gaps. Along its edge, clumps of rock the size of mountains crash and fuse. Each impact flings smaller fragments outward, a cosmic spray of leftovers. Some of those fragments will fall inward, feeding the planet's growth. Others will find escape velocity and leave forever, propelled by gravitational ricochets between giants. Those are the future wanderers, the galactic nomads. A quirky tidbit. Simulations show that when a Jupiter-sized planet migrates through a young disk, it can eject as much as 99% of the system's early debris. One researcher described it as cosmic spring cleaning on a catastrophic scale. Every planet's birth, it seems, requires a little violence. Historians still argue whether this phase of creation, chaotic, destructive, wasteful, is an unfortunate side effect or an essential part of building order. Without collisions, there'd be no planets. Without ejections, there'd be no wanderers. The line between making and breaking, it turns out, is just another orbit. You move inward toward the heat, watching the colours shift from icy blue to molten orange. Near the young star, rock melts and reforms, birthing the seeds of terrestrial planets. Deeper out, beyond the frost line, ices condense, creating comets. You realise that comets are, in a sense, fossils, time capsules of the disk's original chemistry, and when they escape into interstellar space, they carry that fossil record to the rest of the galaxy. You can almost hear the hiss of sublimating gases, the brittle pop of frozen crusts cracking under newborn sunlight. The smell here, if you could smell, would be a mix of ammonia, carbon monoxide and starlight, a cold, metallic sweetness. Over time, the newborn system stabilizes. The planets settle into their orbits, the gas thins, the light clears. What remains is a family, a star and its children, each with their own moons and scars. But the outcasts, those ejected bodies, continue outward, cold and unobserved. You follow one now, leaving the warmth behind. It spins slowly, cooling as it goes, its surface hardening into glassy ice. Cosmic rays carve it, darken it, erase the last fingerprints of its origin. Millions of years pass in seconds. It becomes anonymous, a piece of the galaxy's background noise, until eventually some random chance, a passing star's tug, a gravitational whisper, redirects it toward a new sun, toward us. You see now how simple the pattern really is. Creation makes fragments, fragments make wanderers, wanderers make discovery. Every interstellar object we find is a clue to how planets elsewhere are built, and by extension how common life might be. That's why scientists treat even a handful of detections like treasure. Each one carries isotopic signatures, ratios of carbon to nitrogen, fingerprints of alien chemistry. If we could ever intercept one, we might hold the materials of another world in our hands. The thought feels sacred, like touching a star's memory. You drift outward again, leaving the protoplanetary disk behind. Around you, hundreds of other stars twinkle, each with their own hidden disks, their own invisible ejections. The galaxy is full of construction sites, each littering the void with fragments. You realize that collectively these processes have filled the Milky Way with a kind of invisible architecture. Billions of tiny bridges connecting one solar system to another. A new perspective settles over you. You're no longer watching isolated comets, but a web of motion, a choreography spanning light years. The interstellar medium isn't empty. It's a vast archive of everything that's ever fallen apart and everything that's still coming together. You think of Oumuamua tumbling like a relic, Borisov glowing with alien chemistry, a TLAS breaking apart before our eyes. They are all pages torn from that same galactic book. We read them when they pass by, but most of the text floats unseen. In the end, you understand that these objects aren't interruptions in the solar system's story. They are the story. Without them, no exchange, no renewal. Without their journeys, every star would be an isolated experiment. You let that truth sink in as you watch one last ejection from a distant disk, a comet newly flung beginning its exile. It's small, bright, insignificant. Yet you know, with absolute certainty, that in a few million years it will drift through another sky. Maybe someone there will point up and whisper the same words you've whispered tonight. What is that? Where did it come from? The universe, after all, loves a recurring question. You smile as the comet vanishes into the black and your drift slows. The next section of this cosmic lullaby waits ahead, softer now, quieter, where wonder meets reflection and the restless search becomes something closer to peace. You've seen the birth of wanderers, now you hover in the space between them, the wide, silent interval where motion pauses just long enough to be noticed. The galaxy hums around you, an orchestra of radiation, gravity and memory, and you realize the next question isn't where or how anymore, it's why. Why do we keep looking up? Why do we chase each faint traveller through the dark when we know it will slip away again? Below you, Earth turns slowly. The continents glow faintly under their cities, their telescopes scattered like jewels across mountain summits and deserts. You drift over Hawaii, Chile, the Canary Islands, the Himalayas, all those lonely outposts where humanity stares into the infinite. The domes open at dusk, and one by one, lenses turn upward like the pupils of a curious giant. You move among them, unseen. Inside, the astronomers are quiet tonight. There's no new interstellar alert, no breaking discovery, just the slow, meditative rhythm of watching. Screens flicker with moving dots. Spectra scroll like ghostly barcodes, and still, the watchers never tire, because every moving point could be the next one. Here's your historical anchor. In 1609, Galileo Galilei first aimed a telescope at the sky. It wasn't much, just a spyglass improved with a pair of polished lenses. Yet with it, he saw craters on the moon, moons around Jupiter, phases of Venus, proof that the heavens weren't immutable perfection, but a dynamic, changeable place. 4 centuries later, we've built instruments 1,000,000 times stronger, but the impulse is the same. The act of looking itself feels holy. A quirky tidbit. At one observatory, there's a coffee pot older than half the researchers. Its sides are plastered with stickers. My other car is a telescope. Cosmos, the original reality show. You're here, with an arrow pointing to a speck. It's absurd and perfect. Because even surrounded by cold data, astronomers remain romantic at heart. They spend lifetimes searching for something they'll never touch, just to prove that distance isn't the same as emptiness. Historians still argue whether this instinct to seek, to catalogue, to stare at what's beyond reach counts as science or faith. Maybe it's both. Science is, after all, a kind of devotion. Hours of repetition, long nights of nothing, the rare burst of revelation. You float above one observer as she adjusts her focus, the glow of the monitor painting her face in pale blue. Her eyes are tired, but when a streak flashes across the frame, a meteor, not a comet, she smiles anyway. Even false alarms have beauty. You drift onward, through the global network of eyes. Radio telescopes in the Atacama listen for whispers of molecules. The James Webb peers past galaxies to the dawn of time. The Vera Rubin Observatory readies itself to map the entire sky in motion, a living atlas of change. The instruments hum in harmony, and for the first time you hear it clearly. The sound of human curiosity, rendered in machinery. You hover above the world, watching the pattern of watchers. It strikes you that we build these observatories not just to find, but to remember. To remind ourselves that the universe isn't static, that there are strangers out there crossing paths with our star. In a century obsessed with speed and self, telescopes are acts of patience. You think of all the people who will never stand beneath one but still look up, tracing satellites and shooting stars with naked eyes. Wonder is democratic that way. It requires no equipment, only attention. Somewhere in a city park, a kid stares at the night sky for the first time and feels that strange pull in the ribs. That tug is the same one that drew Newton, Halley, Caroline Herschel, Vera Rubin, and Gennady Borisov. Curiosity, it seems, has a gravitational field of its own. The Earth turns beneath you again, revealing the ocean. The lights vanish, leaving pure darkness, interrupted only by lightning far below. You realize that the planet itself, this fragile blue marble, is just another object drifting through space, our own interstellar traveller in training. Someday, long after humanity is gone, Earth's orbit will decay, the sun will swell, and fragments of this world may be flung outward to join the same galactic current you've been following. Even home isn't forever. That thought doesn't frighten you, it calms you. There's a strange serenity in the idea that everything that exists is part of the same migration. The stones beneath your feet, the comets beyond Neptune, the dust between stars, all share the same motion toward diffusion. Nothing stays, but nothing truly disappears either. You drift closer to the upper atmosphere, watching auroras ripple at the poles, green curtains swaying in solar wind. The colour reminds you of Borisov's tale, that icy breath of cyanide and carbon monoxide. You imagine its fragments still out there, faintly orbiting the sun, invisible but present. Maybe when auroras shimmer like this, they're not just the sun's doing. Maybe it's a cosmic greeting from old visitors, their atoms mingling with ours at last. Down below, the world sleeps. Above, the galaxy keeps turning, and you, suspended between them, begin to understand why we keep looking up. Because the act itself connects us. When we gaze into the infinite, we see our own reflection stretched across light years. You remember something Carl Sagan once said? That we are a way for the cosmos to know itself. You smile, because now you see that it's mutual. Every interstellar visitor that passes through is also a way for the cosmos to remember us. Each one brushes against our gravity, steals a little of our dust, carries it onward. Maybe somewhere, millions of years from now, a fragment of ATLAS or Oumuamua will drift into another system, and someone there will point up and wonder where it came from. The universe, you realize, is a conversation carried on through motion. We don't need words, we have trajectories. The thought softens your breath. The search continues, but it's no longer frantic, it's reverent. You glance outward, into the direction from which new visitors will someday come, and whisper quietly to whoever might be listening. We're still watching. You hover in the hush above Earth, the echo of that whisper still rippling through the dark. We're still watching. The words dissolve into starlight, and somewhere beyond even your imagination, a new fragment begins its long fall toward the sun. You can't see it yet, but the next generation of telescopes will. Because now, humanity isn't just waiting for chance, it's preparing. The future of detection is already unfolding. You drift over the Andes to the white dome of the Vera Rubin Observatory, its mirrors gleaming like a sleeping eye about to open. When it does, when that enormous shutter rolls back, it will scan the southern sky every few nights, creating a time-lapse movie of the universe. Its legacy survey of space and time, LSST, will track billions of stars, galaxies, and moving objects. Among them, somewhere, will be the next interstellar wanderer. You descend through its dome in your dream, watching engineers calibrate the 3.2 gigapixel camera, the largest ever built. It's so powerful that it could photograph an entire mountain range and spot a single candle flickering on a distant ridge. The hum of servers vibrates underfoot, the air electric with possibility. You can smell ozone, warm plastic, and optimism. Someone whispers, "We're about to see everything." Here's your historical anchor. In 1781, William Herschel discovered Uranus by accident, while scanning the sky with a homemade telescope. That single act of curiosity doubled the known size of the solar system. 2.5 centuries later, Rubin's machine will expand that vision beyond imagination. Herschel had to squint and sketch. Rubin will record the universe in terabytes. You drift through the observatory's main hall where posters line the walls, artists' renderings of comets, asteroids, and exoplanets. One of them reads, "The next messenger is out there." Beneath it, a handwritten note, "Keep the coffee flowing." You smile. Even at the frontier of science, caffeine remains the real propulsion system. A quirky tidbit. One data scientist working on the LSST pipeline has programmed an algorithm nicknamed Oumuamua Hunter. It uses machine learning to identify any object whose orbit looks suspiciously unbound. During tests, it accidentally flagged the International Space Station as an interstellar candidate, which, depending on your sense of humour, was either poetic or prophetic. Historians still argue whether technology shapes curiosity or the other way around. Did telescopes invent wonder, or did wonder invent telescopes? You suspect it's a feedback loop. Each feeds the other endlessly. Humanity keeps building sharper eyes because the act of seeing further makes us hungrier to see further still. You drift beyond Chile now, towards space itself, where the next generation of telescopes already watches from orbit. The Nancy Grace Roman Space Telescope, Euclid, and Gaia, each one mapping the heavens with precision no human hand could match. Gaia, in particular, is quietly rewriting the galaxy's map, measuring the motions of over 1 billion stars. From those motions, scientists can trace the gravitational fingerprints of passing objects, tiny anomalies that might someday soon reveal interstellar visitors before they even arrive. It's like watching astronomers learn to hear footsteps in the dark. Below you, small private observatories are joining in, robotic telescopes that run themselves, scanning and reporting automatically. A few are connected to citizen science networks. Somewhere, perhaps right now, a teenager is coding a detection algorithm that will catch the next Oumuamua before the professionals do. Discovery, it seems, has been democratized, and beyond observation lies ambition. You glide toward a concept still being drawn on whiteboards, the Comet Interceptor mission, set to launch in the late 2020s. Its goal? To wait patiently in space, ready to chase any newly discovered visitor. When a target appears, it will deploy its probes and race to meet it head-on. For the first time, humanity plans not just to see a wanderer, but to greet it. The image fills your mind, a spacecraft skimming past an alien comet, its cameras flashing, its instruments tasting the chemistry of another world's debris. For a moment, science fiction and reality blur. You can almost feel the vibration of the engines, the metallic heartbeat of purpose. Humanity, the latecomer to the cosmic party, is finally learning how to shake hands with the guests. You think of all the tiny human details that make these grand machines possible. The welders, the coders, the night shift engineers. Each of them adds a piece of themselves to the technology, so that when a future probe touches an interstellar comet, it carries traces of us all. You float farther out, into a vision of what comes after. Imagine telescopes stationed in deep space, free from Earth's light, scanning the void from the Kuiper Belt or beyond. Imagine AI networks that monitor every pixel of the night sky, detecting faint visitors in real time. Imagine a fleet of microprobes, each waiting to intercept a comet, to sample, to listen. Humanity's reach, once measured in miles, will soon be measured in star systems. But even amid that ambition, the heart of it remains unchanged. The astronomers will still stand under the same sky, still gasp at the same streak of light, still feel that same quiet awe. You hover above them now, seeing both past and future compressed into one view. Galileo with his crude lenses, Rubin's robotic cameras, a child with a phone app pointed at the stars, all linked by curiosity, all looking up for the same reason. You realize that the future of detection isn't just about technology. It's about intimacy, the deepening conversation between the universe and its observers. Each new instrument is another ear pressed closer to the infinite. The cosmos speaks rarely, but when it does, we want to be listening. So you keep drifting, your vision widening until you can see the spiral arm of the galaxy itself, luminous and alive. Somewhere in that swirl, another interstellar object is already on its way. Maybe years from now, a new alert will ping through the networks. 4I/name TBD. Possible interstellar candidate. The cycle will begin again. For now, you let yourself rest in the glow of potential. The telescopes are watching, the software is waiting, the sky is speaking in its slow, patient code, and you, hovering between stars, whisper the only prayer science ever truly utters. May we notice when the universe knocks. The spiral of the Milky Way turns slowly beneath you, an endless river of light moving through time. For a long while you just drift, quiet, weightless, content. Somewhere in that gentle rotation, Oumuamua keeps tumbling, Borisov keeps drifting, and the dust of 3I/TLAS keeps fading into starlight. The story of interstellar visitors isn't over, it's only paused. You can feel the pulse of their trajectories like a heartbeat running through the galaxy. Below, Earth glows faintly blue, wrapped in thin clouds and electromagnetic chatter. All those telescopes, those observatories, those sleepless humans staring upward, they're part of this same living network now. Every lens, every algorithm, every heartbeat contributes to the cosmic listening. The solar system no longer feels like a lonely island. It's a porch light burning in a vast neighborhood. Here's your historical anchor. In 1977, two small spacecraft, Voyager 1 and 2, were launched into that neighborhood. They've been traveling ever since, carrying golden records etched with greetings in dozens of languages and songs from Earth. They were the first objects built by human hands to reach interstellar space. It's poetic symmetry. While fragments from other stars drift in, our own emissaries drift out. The exchange has already begun. You drift beside one of them now, Voyager 1, its dish glinting in the weak sunlight. The recording of a heartbeat still rides within it, travelling silently toward unknown listeners. You realise that these little machines are humanity's own Oumuamuas, artefacts of our curiosity tumbling endlessly through the dark. If some distant intelligence ever finds one, they'll learn what we once were, a species that built mirrors to see itself among the stars. A quirky tidbit. When Voyager's engineers turned its cameras back toward Earth in 1990, at Carl Sagan's suggestion, they captured the now famous pale blue dot image. The entire planet, every history, every song, every heartbreak reduced to a single pixel. That photograph became our self-portrait, a reminder that even the grandest stories begin small. Historians still argue whether the interstellar age began with Oumuamua's discovery or with Voyager's launch. But the truth is softer. Both events mark the same turning of the page. The moment we realized that the boundary of our solar system was porous, that messages can travel both ways. You let your gaze sweep outward. Each star you pass seems less like a destination and more like a sentence in a continuing conversation. Oumuamua spoke first, cryptically. Borisov replied in ice and cyanide. Atlas whispered through dust and silence. And humanity, with its probes and telescopes, has answered back, not with certainty, but with listening. You drift through that chorus of motion until the constellations themselves start to blur. Somewhere in the distance you sense the faint outline of what comes next. A time when interstellar visitors will no longer be accidents but invitations, when spacecraft will rise to meet them, sample their ices, taste their histories. Maybe one day, when technology and patience align, we'll even send something back. A deliberate messenger, not just an ejected fragment, but a conscious greeting to the galaxy. The thought makes you smile. Every era of discovery begins with a mistake, the wrong orbit, the unexpected flash, and then becomes a tradition. Interstellar detection will be no different. Someday, another 3i will be ordinary, another dot in the data, another whisper in the cosmic wind, and maybe that's how it should be. The extraordinary, once understood, becomes home. You drift a little farther until you can see the solar system as a single shimmer in the dark. It looks fragile, but not lonely. You realize that home isn't defined by walls or gravity wells. Home is where curiosity points outward and says, "Come in." The sun flares once more, lighting your path. Its warmth spreads slowly through the void, catching the scattered particles of Borisov's dust, the fading glitter of Atlas, the unseen fragments of Oumuamua. For a moment they all glow together, a constellation of visitors, temporary yet eternal. You imagine drawing lines between them, forming a shape that means welcome. You take one last look around. Every discovery so far, each faint dot on a screen, wasn't a conclusion but an invitation. Each taught something about survival, impermanence, and the beauty of noticing. You turn toward Earth again. Its oceans shimmer, its lights wink, its telescopes blink. Down there, people are still awake at strange hours, waiting for the next alert. You whisper to them across the void. Keep your domes open, keep your software tuned. The universe is patient, but it always knocks again. And then, softer, because every lullaby needs a closing line. You murmur to yourself, the next visitor is already on its way. You just haven't seen it yet. You feel the story slow, the way waves flatten before reaching shore. The galaxies dim to embers, and the silence deepens into comfort. You drift through it gently, your thoughts dissolving like the last grains of comet dust in sunlight. Every sound, every motion, every question begins to fade. The universe hums a low note beneath you, steady as breath. You think of Oumuamua, Borisov, a TLAS. How briefly they appeared, how quickly they vanished. They weren't visitors so much as reminders that even the smallest flicker can change how we see the sky. You realize that wonder doesn't require proof, it only requires presence. The air, or what passes for it out here, feels cooler now. The stars blur at the edges, melting into a soft fog. Your body relaxes, your heartbeat syncing with the slow rotation of the Earth far below. Somewhere, a telescope dome closes for the night. Somewhere else, another opens. The rhythm continues without you needing to hold it. Let your breathing match that rhythm. In, the quiet of space. Out, the weight of everything you've learned. The universe has no hurry. It will still be here when you wake. You turn one last time toward the faint light of home. The blue marble glows softly, wrapped in its thin veil of air. You can almost feel gravity calling you back, not to pull you down, but to cradle you. The story ends not with discovery, but with rest. The travelers keep traveling, the watchers keep watching, and you can finally close your eyes, knowing the cosmos is wide awake on your behalf. Good night, traveler, sweet dreams.